We're live at GSX over here in Chicago, Illinois. Glad you could step in and join us. With me, I've got Alejandro from Autel. Now, we've been talking about urban turbulence or microclimates in urban areas, and some drones are set up to deal with it really well, other drones are not. And Alejandro had never heard about urban turbulence and microclimates until this morning.
A little new to me,
right?
But learning. Great teacher over here.
So we went through a couple of aircraft we're not going to mention that weren't able to handle microclimate or urban turbulence very well. So we thought we'd bring, since Alejandro works for Autel, we figured we'd bring the EVO in and we'd test the EVO out. And so I'm going to go ahead and let you set this up and I'll tell the audience what's going on when we do that. So what we have happening is on the other side of this obstacle, we have set up a 19-mile-an-hour fan. We'd really like it to be about 25 miles an hour, but the best speed it can do is about 19 miles an hour. We've got an anemometer that we've measured it with to make sure it's doing what we want it to do. And we've taken Alejandro through, we figured out where the microclimates are involved in this tube here. So now what we're going to do is let's see how well Alejandro, and more importantly, the EVO can manage wind from a multitude of angles. Now, most of our viewers may or may not be aware that the aircraft are tuned to manage wind usually from the front and from the rear, but not a whole lot of side-to-side control. I think we're going to take, after we get over the top of this obstacle, and we want you to watch closely as the aircraft goes over the obstacle, after we do that we're going to put the drone directly into the wind and show you how it behaves in different quarters. You ready, Alejandro? All right, let's see if we can do this one. For our viewers, there's a fairly stiff breeze down here, which is dead air, and there's an inverted rotor up here. So Alejandro needs to bring this in close to the obstacle, come up and over without the aircraft driving in due to negative pressure. Good, looking good. Strong negative pressure here. All right, now we're in the positive rotor. Now he's got to bring it down in the face of a very high wind. So he's going to follow the angle down. You can feel it trying to get sucked backwards there, can't you, a little bit? Yeah. Well done, well done, well done. All the way down to the bottom. Outstanding. Well done, Alejandro. Woo-hoo.
How was that, Alejandro?
Oh, that was great. It's easy when you have such a great teacher telling you and walking you through every step.
So what do you think? Is this something that people should know about, microclimates and how to manage a drone?
Oh, definitely. I mean, I know I've run into it flying, near buildings, near our facility up in Seattle. A lot of inclement weather up there, so we've definitely felt this a few times, during our testing, and definitely our customers as well. So definitely something that you need to learn about. That way you can experience it yourself.
I'll tell you what, we're going to wrap up by, I'm going to move the fan over, and let's have you do that exercise in just into the wind so people can see how the nose, the quarter, and the side, and the quarter, and the rear all respond to heavy winds. So there are viewers, that way they can understand how this aircraft manages, because there are other aircraft of a similar form factor that can't do very well what you're about to show them. Let me get the fan set up. Okay. All right. Nice shot the edge. Nose in. Ideal. Give it a quarter. Now for the viewer, notice that when it's quartered in, it has the same reaction as if it's the nose. In other words, this is tuned to manage quartering winds very well. Give me a side, please. Outstanding. Now, since we have a side view here, if I can get you to bring the camera around so you're more viewing on the front there. As we cover this over, you see the aircraft has a tendency to want to move in, because it's responding to the negative pressure. This aircraft has a very minute movement. All right, give me a rear quarter, please. Excellent. Look, too much. Rear quarter. There we go. Perfect. Again, watch what happens when I block. The aircraft's managing the wind fine. And finally a rear, and we'll be done. Let's put it down. So as you can see, the EVO can manage wind in a variety of different positions and configurations. Check one out for yourself.